Our next lesson is called Piecewise and Step Functions in Context. So in example 1, it says use the graph to complete the table. So looking at the graph, on the x-axis, we have weight in ounces. On the y-axis, we have cost in cents. And I do want you to add in here a break in the graph. Please make a little mark like this to show that there's a break in the graph. What I mean by that is, do you see that there's a 0 in the corner, but then it jumps to 45, and then it does not follow that same scale for the remaining part of the graph. So we want to show that it jumps up to 45 and then goes by ones from there. So if I'm looking at the table of values, weight in ounces is already filled in. They want us to find the C of X or Y values. So also let's put a little note here that this is C of X, not Y. Okay, and we want to put down the cost of these different weights for our X values. So when X is 2, if I find this on the graph and I look at 2 and I follow it up, I see that I'm at a cost of 48 cents because that circle is filled in. For 2.2, we're going just a little bit past, and we end up having to follow it up and go to the next line, which is actually at 50. For 3, when I follow that up, I have a closed circle at 50. So that means the answer is 50. For 3.5, which is halfway between the 3 and the 4, when we follow it up, we hit the line for 52. And then for 4, a weight of 4 ounces with an X value of 4, when I go up, I see that it's also 52. Now remember from our previous lessons that this is called a step function because it looks like actual steps. Remember that open circles means that the number is not included and closed numbers means that it is. So for part A, they would like us to write a formula involving step functions that represents the cost of postage based on the graph above. So remember we have C of X as the identification for our Y values or our output. And then we want to make sure we have an equation for each line that we see. So for the first horizontal line, we are crossing the y-axis at 46. So we'll set up our bracket and we will put 46 first. We are using that from 0 to 1. So 0 is less than X is less than or equal to 1 because the 0 has an open circle, but the 1 has a closed circle. The next line, if we were to extend it, would cross the y-axis at 48. So we have 48 that we're going to use from 1 to 2. So 1 is less than X is less than or equal to 2, again, because an open circle on 1, but a closed circle on 2. Our next line would cross at 50. So we have 50 that we're using from 2 is less than X is less than or equal to 3. The next one would cross at 52. So you can start to see the pattern here. We have 3 is less than X is less than or equal to 4. After 52, we have 54. For 4 is less than X is less than or equal to 5. And lastly, we have 56. We're going to use that from 5 is less than X is less than or equal to 6. In part B, Trina went to the post office to mail a letter to her sweetheart for Valentine's Day. If it cost Trina 54 cents to mail her letter, how many ounces did it weigh? So you have two ways you can look at this. You could go back up and look at the graph, find 54 cents, and follow it over. But the problem is that it could be any of those. So we have to make sure we answer like that when we answer the question. Or you can look at your equation and see where is it 54. So I see that that happens right here. And now I can tell again that we have a range of answers that we can use because you can see our domain there was from 4 is less than X is less than 5. So we were given a C of X value and they want us to find X values that work. So now we know her letter was more than 4 pounds. And notice I said more, not including, because it was an open circle or just less than, no or equal to. But it has to be less than or equal to 5 pounds. All right, moving on to example 2. It says, during a snowstorm, a meteorologist tracks the amount of accumulating snow. For the first 3 hours of the storm, the snow fell at a constant rate of 1 inch per hour. The storm then stopped for 2 hours and then started again at a constant rate of 1/2 inch per hour for the next 4 hours. In part A, they want us to draw and label a graph that models the accumulation of snow over time using the data that the meteorologists collected. So we want to take a look at this first section. For the first 3 hours of the storm, so we know that that means up till x is equal to 3. The snow fell at a, this is important, constant rate. So that implies that we have a linear section, which means it has a constant rate of change, and it should make a line. And that rate is 1 inch per hour. So when we look at our graph, we have some labeling that we have to do. We have our x-axis, which is going to be number of hours. And then we have our y-axis, which is going to be the amount of snow. And that is in inches. So remember, that all has to do with dependent and independent variable. The amount of snow depends on the number of hours that we're looking at of it falling. So when we see 1 inch per hour, that means we have a slope of 1/1, which means we're going up and to the right. But again, this is only for the first 3 hours. So that means we're only going up to x is 3, and 3 included. So we want to make sure we're counting 0 is less than or equal to x is less than or equal to 3. We're only doing that for the first 3 hours. So starting at a y-intercept of 0, because if no time has passed and no snow has fallen, it's going to go up 1 to the right one, up 1 to the right one, up 1 to the right one, only to that part, because there's my x equals 3 where we know we need to stop for the first section. So my first section looks like this. So now I'll switch colors so you can see the second part. It says the storm then stopped for 2 hours. So when it says stopped for 2 hours, that means that it's the same amount over that time. Nothing is changing. So to show that, we need to draw a horizontal section of the graph from 3 up to 5 to show that the amount of inches of snow has not changed, but time has gone on. Then we look and it says it started again at a constant rate of 1/2 inch per hour. So again, we see those words constant rate, which means the same thing as before. It's a linear section, but this time it's 1/2 inch per hour. So we have 0.5 over 1, okay? So you're going up, 0.5 over 1 is just 0.5, and 0.5 as a fraction is 1/2. So our slope is 1/2. We're going up 1 to the right 2. So up 1 to the right 2, but we're only doing this for the next 4 hours. So that means from 5 up to 9. So once we do 2 more points, we're at that spot and we're going to connect them. And at that point, we're done. We're not going to draw an arrow at the end because it does not say anything about continuing past those 4 hours. So now that we've drawn the graph, it says write a piecewise function that would represent this graph. So we have 3 pieces, 1, 2, 3. So thinking back to what we've learned already, we need to write one for each piece. So if I'm looking at piece 1, I'm going to pick 2 points, and I see I'm going up 1 to the right 1, which we knew from before. So I have a slope of 1. So 1 would be the number that goes in front of x. So we'll name our function f of x. Our first piece has a slope of 1, so that would be the number that goes in front of x. Remember, you're thinking of y equals mx plus b. And it's crossing the y-axis at 0, so it has a y-intercept of 0. So no need to write plus 0. You then need to list the domain that we're using it. We're using it for x values of 0 up to 3. So 0 is less than or equal to x is less than or equal to 3. The next section is a horizontal line that if I were to extend it, would cross the y-axis at 3. So it's f of x equals 3, and we're using that from 3 to 5. Now we already counted 3 in the previous domain, So when we write the 3, it's going to be less than x because 3 has already been counted somewhere else, but we'll go up to and including 5. Now remember, if you don't want to include a number, you can usually have a choice, but here we need to have the less than or equal to at 3 because of the way it was worded up here. It said for the first 3 hours, so that includes the 3. So sometimes you have a choice where you can include it. This time we did not. We need to include it in the very first part of our equation. Now for the last section, we want to take a look. We see that the slope is up 1 to the right 2. So we have a slope of 1/2. That's what's going to go in front of the x. And for the purple section, our last section, we do not see where it crosses the y-axis. So we either have to extend the picture, which means we'd be here, here, and here, which looks like we're going to cross at 1/2. But I want to go back and do it algebraically because we need to be exact, and it is a good reminder and review of a skill that we need during this chapter. So we're going to find the y-intercept. Remember to do this, you need 1 point off the line. So I'm going to pick this one right here, 7, 4. So we'll use 7, 4. You can pick any point on the line. That will be our x and our y. And then we're going to use y equals mx plus b. We will plug in everything we already know. From our coordinate, we know that y is 4. We already found the slope. It was 1/2, so that goes in for m. Our x comes from the coordinate. That's a 7. And then we are trying to find b, which is the y-intercept. So we get 4 equals half of 7 is 3.5 plus b. And then we would subtract 3.5 in order to get b by itself. So it is indeed 0.5. Okay, so we'll put plus 0.5. And we are using that from 5 to 9 and not past that. So we're going to go 5 is less than x is less than or equal to 9 because the 9 is included. Part C, if the snowstorm started at 6 p.m., how much snow had accumulated by midnight? Okay, so we're starting at 6 p.m. and we're going to midnight, which is 12 a.m. So you're looking at 6 hours from the starting point, so the 6th hour. So that means we want to look at an x value of 6. So I'll go up and find 6 and follow it up. And I see that it's hitting right there at 3.5. So I find this 0.6, 3.5. And I see that it's 3.5 inches. Now you could also do that algebraically. If you know it's the 6th hour, you can go up to your equation, and that means you'd be using f of x equals 1/2 x plus 0.5, but you would be finding f of 6. So you would replace x with 6 and do plus 0.5, but you're still going to get the same thing. Half of 6 is 3 plus 0.5, which is 3.5. And that should happen. So either way, you can see that the answer is 3.5. Okay? And that concludes your lesson on piecewise and step functions in context.